Alright, let's look at stress, strain, and Young's models. Stress, strain, and Young's models. So, what is stress? What is stress? Stress is defined as the ratio of what? Force per unit area. Are we there? Stress is the ratio of what? Force per unit area. And stress has the same unit as pressure. Pressure on its own is what? Still force per unit what? Area. So what's the difference between stress and pressure? When you talk about stress, stress has to do with the internal pressure of a body. That's the pressure within the body of a material, like a wire. When you stretch it or compress it, the stress on the atoms or the pressure on the atoms, the unit area of those atoms is called what? Stress. Now when you say pressure, pressure has to do with an external force per unit area on a body. You understand? Like if you have a plane here and then you apply a force on it, maybe the area you're applying the force is just between here and here. This is when we talk about pressure. Understand? So the more you increase the area in contact, the lesser the pressure on that point. So we are not here to talk about pressure. We are here to talk about what? Stress, strain, and Young's models. So what is the unit of stress? The unit of force is in Newton, and area, the unit for area is meter square. So the unit of stress is what? Newton per meter square, or you write it this way: Newton per meter square. That's raised power of 2. So that's the definition of stress. So which also you can write it as what? Capital letter F over A in what? Newton per meter square. So that is it about stress. So the next one, we're going to look at what is called strain. We're going to look at strain. So strain is defined as the ratio of extension of the length of a body to what? To the original length of that body. So to see how a body is strained, when you talk about strain, that's you are looking at how deformed the body is from its what? Original length. How deformed the body is from its original length. That's what you are trying to measure. Like when you say you want to strain something, maybe you draw that thing beyond. You cause an extension on that material. Beyond the material extend beyond its original length. That means you are straining it. So strain is what? The measure of what? Extension over what? Original length. And extension is a length in itself. Its unit is what? Is in meter. And the original length is also its unit is also in what? In meter. So meter will cancel meter, thereby making strain to have what? No unit. So strain has no unit. So also in terms of notation, strain equals to what? Extension, small letter e divided by original length, in which you can write small letter L, or you write capital letter L, then put a subscript of 0 or not there, meaning original length. So we move on to the next concept, which is what Young's modulus. When we say Young's modulus simply measure what? The ratio of stress to strain. Stress over strain. With Young modulus, you are trying to look at the factor, the factor in which a body can withstand certain pressure or stress, certain stress or strain, the ruggedity of the body. That's what the concept of Young's modulus is about. So Young's modulus is what? Stress over strain. And we know that the formula of stress is what? Force over area. And the formula of strain is what? Extension over original length. So if we simplify this division of fraction, you end up having F over A times what? L, original length, over extension. So which is F L naught divided by A times extension. And what's the unit for Young's modulus? Of course, you see force here, we have Newton over area. That's a Newton per meter square, and we have a length which is in meter over another length which is in meter. So meter will cancel meter. So the unit of Young's modulus will be what? Newton per meter square. So the unit of Young's modulus is still what? The unit of stress or pressure. Are we there? And then the dimensional the dimensional unit the dimensional unit of Young's modulus or stress equals to what? Capital letter M. Sorry, let me write it somewhere where it could be seen. The unit of Young's modulus is what? The dimensional unit. Our unit is capital letter M per length per time square. So this is the dimensional unit of Young's modulus. So here are things to take note. Young's modulus is stress over strain, which accumulates into what? F times L naught over 8 times E. And then strain is extension over original length. And stress is force over area. Thank you.